So let's take a look at a few more examples of simplifying. Let's say I have the square root of 32 and I asked you to simplify it. So you'd simplify that to square root of 4 times 8, and that's the same thing as saying the square root of 4 times the square root of 8, but I know the square root of 4 is 2, and I have square root of 8. But I notice, hey, I can still simplify this. So always ask yourself, can I still divide this by a number that has a whole number root? And in this case, 8 can be broken down into 4 times 2. So I'm then going to take this and break that into square root of 4 times square root of 2, but square root of 4 is just 2, and I still need to keep this 2 here. So I have 2 times 2 times the square root of 2, which is 4 square root of 2. Now if I had come back here originally and I had changed this and said that this was equal to the square root of 16 times 2, I would have gotten to that answer right away. But if you don't see the largest number on that original list that I showed you of whole number square roots, then you're going to want to take a look at this list and just make sure that you check, is that number underneath the radical sign completely simplified? So here we'll take a look at another example. I have 2 square root of 40. So I can break that down into 2 square root of 4 times 10. And so that's 2. I can break this apart into its 2 pieces because of our little rule. So that's 2 square root of 4 times square root of 10. But the square root of 4 is 2. So now I have 2 times 2 times square root of 10. And that gives me 4 square root of 10. Now I could take 10 and say 2 times 5. But that does not help me at all because the square root of 2 is not a whole number, and the square root of 5 is not a whole number, so I'm going to leave that just like that. Now, here's another little rule that we can use, and that says if I have the square root of x divided by y, that's the same thing as saying the square root of x divided by the square root of y. So let's take a look at an example of how that might work. So if I have the square root of 49 over 81, well, that's equal to the square root of 49 divided by the square root of 81. Well, the square root of 49 is 7, and the square root of 81 is 9. So there it is. That's as far as I can reduce it. Here's another example. I have the square root of 12x squared over 25. Well, that's equal to the square root of 12x squared divided by the square root of 25. Okay, and I'm going to keep simplifying using things that we've previously learned. Well, I know the square root of 25 is 5, so that part's easy. But here I have the square root of 12x squared, and I can break that down into the square root of 4 times 3 times x squared. And then I can break that into its pieces because of our little rule. And so I know that this is equal to the square root of 4 times the square root of 3 times the square root of x squared. But I know the square root of 4 is 2. The square root of 3 is going to have to stay the square root of 3. The square root of x squared is x. I'm then going to rewrite this because I don't want this x sitting behind this square root of 3 sign, because sometimes what happens is students make a mistake and they take that all the way over. So I'm going to make it 2x in the front, square root of 3 over 5, and that's as far as I can reduce it. And here's another example. Square root of 50x squared y squared divided by 49. So I can break that into its pieces. Square root of 50x squared y squared over the square root of 49. That's the same thing as saying the square root of 50 times square root of x squared times square root of y squared. Square root of 49 is 7. Well, this is the same as saying the square root of 25 times 2, and the square root of x squared is x, the square root of y squared is y, that's over 7. Well, this breaks down into the square root of 25 times the square root of 2, but the square root of 25 is 5, and then I have the square root of 2 times x times y over 7, and that becomes 5xy square root of 2 over 7. Now, here are some more examples of simplifying, and these are a little different because this is saying 2 square root of 5 plus the square root of 6 plus 4 square root of 5 plus 3 square root of 6. I don't have anything being multiplied here. I can't take anything out of the radicand sign, but I do ask you to simplify. And what I notice is I have a square root of 5 here and a square root of 5 there. And what I can do is rewrite these because of our commutative property, and I'll put all square root of 5s together, and I'll put all the square root of 6s together. And what I can do then is it's similar to just thinking that these are like variables. And so it's combining like terms, basically. And what I have here is I have 2 square roots of 5 plus 4 square roots of 5, so I have a nice total of 6 square roots of 5. And here I had a 1 square root of 6 plus 3 square root of 6, so that gives me a nice total of 4 square roots of 6. And so that's how you would add your roots. Now let's say I want to multiply, so I have 3 times square root of 3 plus 5. Well, here we're going to have to use our distributive property just like we always have in the past. And what I notice is that I have square root of 3 times the square root of 3 and square root of 3 times 5. Well, square root of 3 times square root of 3, actually that follows into that formula, or if you didn't remember that, you can say, hey, this is the same as saying square root of 3 times 3, which is the square root of 9, which turns out to be 3. And this 5 times square root of 3 is just 5 square root of 3. I can't do anything else with it. So my answer is 3 plus 5 square root of 3. Now you also might see something like solve, and solve would look something like this. That means when we have solve, it's an equation, and we want to find out what is the value of x. So when I solve, what I do is I'm going to get everything that's not under the radical sign onto the other side of the equation. So here I'm going to subtract 15 from both sides, so I get a negative 9 over there. I'm going to divide both sides by a negative 1, so I end up with square root of x equals 9. Well, what I can do is this little trick that says, hey, if I square the left-hand side, I can square the right-hand side. So if I square the left-hand side, I know that the square root of x squared is just x, because that was one of our little formulas. But if the square root of x squared is x, I have to square this side also, and 9 squared gives me 81. So if I were to plug 81 back inside here, well, what is the square root of 81? It's 9. So 15 minus 9 does give me 6.